Okay, today I'm going to teach the integration chapter, and yeah, to be honest, this is one of the hardest chapters for me, because as a teacher I think this chapter is very hard to make students understand. However, okay, I will do my best here to make you understand how to find the area and then how to find the volume. And then okay, so okay, here I provide few diagram, and yes, and then I will teach you how you're going to see whether you need to integrate in y acid or you need to integrate in x acid. Okay, so let's start to look at the first diagram. Okay, first you see this diagram. Okay, when you see this diagram, normally the exam question will ask you to find the shared region. Okay, in order to find the area of the shared region, okay, what you need to analyze first before you start to find is that you have to determine whether you want to use x acid or you want to use y acid to find the area. Okay, for example, for this one, if this one, okay, for this curve y equal to kx minus 1 square, if you integrate on the y acid, which area you got? Okay, do you see this curve? If you integrate in the y acid, you will get the curve like this. Okay, I just simply drop out. Okay, if you integrate at the y acid, this is the area you're going to get. Let's say this is A and this is x equal to 3. This is y, this is x. Do you see that? Means if you integrate this curve in the y acid, all the area here will from this curve go down to the y acid. See, he will go down to the y acid. Okay, this is the meaning by integrate the y acid. Okay, means you integrate the curve at the y acid. If you integrate the curve at the x acid, where you got this the curve. So where is x acid? X acid is this one is x acid. So you integrate the x acid, you will got here. See, this is the shaded region they want. Remember? Okay, so if when you integrate the y acid, you will got the area here. But then if you integrate at the x acid, you will got the area here. So obviously, for this example, you have to integrate at the x acid. Okay, so when you integrate at the x acid, okay, let's say we give this point a name. Let's say we give this point as a B. Okay, means, okay, now you have to integrate here at the x acid, correct or not? So first I write the integrate simple, and then from the smaller to the bigger value. Smaller value I write bottom, bigger value I write on the top. Okay, and because this is, we are integrate on the x acid, so behind here I write dx. Dx it means we differentiate the x acid. Okay, so we integrate at the x acid, we write dx at the back here. Middle we will write y. Okay, then after that, what you need to do, you just substitute the whole y equation here. Y will equal to what? Y will equal to k bracket x minus 1 square. So b to 3, and then we will got k x minus 1 square dx. Okay, that's all, and then you just do the integration. You can easily find the area. Okay, so I repeat one more time. When you find that actually this curve you want to integrate at the x acid, first thing is you straight away write dx. When you write dx, inside here will be y. If you write dy here, inside here will be x. Okay, if you got the y here, what you need to do next is you have to put the whole equation for y substitute back into here. Okay, you cannot straight away integrate y and then you will got y squared divided by 2. Then you will got it wrong. Because this one means you have to substitute whole the y equation back to here, become something like this. Okay, and then for this integrate symbol, the bottom you write the smaller value and top you write the bigger value. Okay, so let's have a look on the second one. Okay, for this one, if he asks you to find the shared region, okay, you will see the curve here. Means what? Means if you integrate the curve, let's say you integrate the curve for x-axis. If you integrate the curve for x-axis, 0 to r means you will got this part only. Do you see? Means that if I draw something like this, okay, let's say this is y equal to fx lah. Okay, mean if you integrate this curve at the x-axis, you will got the area. You got the area here only. If you integrate, let's say from 0 to r, you only get this area in the x-axis. Okay, so if let's say suddenly you think that maybe you want to integrate on the y-axis, so what will happen if you integrate this curve in the y-axis? Okay, let's say we got something like that, and then this curve is something like that. We got one. Okay, if you integrate in the y-axis here, you have to determine you want to from this point integrate to where. If let's say you want to from this point integrate, let's say you want to from A integrate to B, then you got the area here only. Okay, so obviously we do not need this area, because you see actually this triangle here, he didn't include this part. Means he didn't include this part, means actually we find this area, it doesn't help. So what we need to do is, for this kind of example, you have to integrate x-axis. After that, you plus the area of this triangle. Then you can find the color region or shared region. So first thing, you integrate this curve in 0 to r, and then you plus the area of triangle. Okay, so let's say I want to find this part first. So this part first you write integration. Okay, and then the smaller value put bottom, bigger value is r, so I put here. Okay, and then I differentiate. I integrate on the x-axis here, I write dx. So obviously here I put y. Okay, and then after you got this area, and then you can plus the area of triangle. So formula for area of triangle is very easy: half multiple base multiple height. Okay, half multiple base multiple height for area of triangle. Okay, then you plus these two area, then you should be able to get the shared region. Okay, let's have a look another two more example. Okay, for this one, he asks you to find shared region. Okay, this one most of students will feel very confused. They might think that they want to integrate on the y-axis. Okay, if you want to integrate on the y-axis, you need to actually find two coordinates on the y-axis, which is the curve will pass through. So actually in this example, you hardly to get two coordinates on the y-axis for the curve. Okay, this one is not calculated because this one is for the straight line. You want for curve because you integrate only for curve. Okay, so obviously you want to find the shared region here. What you need to do, you need to integrate the whole part here. So let's say you got this one. Okay, means this is point A, you continue down. Okay, if let's say 0, because point A, this one is 1, 6, means 0 to 1. Mean if you integrate the curve from 0 to 1, you can get the whole region. After you get the whole region, you just minus the trapezium here. Do you see a trapezium here? You see a trapezium here? Maybe I move up a bit to have you easy to have a look. Okay, means what? Means you integrate this part 0 to 1, you integrate for this curve, so you got whole area here, and then you minus the trapezium inside. Do you see the trapezium inside? Okay, so this is the way to find the shared region. Okay, and then this one, if you want to integrate y, is hardly for you to find the coordinate to integrate on y. Okay, so for example, if you really can find, let's say this is b, from this coordinate to b, you integrate for this curve, you will get this area, and this is not the area we want, and then even we get this area, it doesn't help. So in this kind of example, you need to integrate for the x-axis. So integrate on the x-axis, what we need to do, we write integration, and then here is 0, and then this one a here is 1 here, so from 0 to 1, integrate x-axis, we write dx. So middle here, we put y. After that, we substitute the whole y equation into her y here, and then we do the integration. Okay, easy? Okay, so let's have a look on this one. Okay, this one is the example which you should integrate in the y-axis. Okay, you integrate in the y-axis. Okay, this one, obviously, you want to find this shared region. So in order to find this shared region, you can integrate the curve from 0 to k. We say this one y equal to k, so obviously this one is k. From 0 to k means you can get the whole region, and then you minus the triangle. Okay, so maybe I draw a small graph here. Okay, let's say we got something like this. Okay, and then a k will be here, 0. So if we integrate this curve we call it x equal to 4y minus y squared. So if we integrate the y-axis from 0 to k, we can get the whole part here. After we integrate 0 to k, we get the whole part. What we need to do is we minus out the triangle. We minus out this triangle. Then we can get the outside part, which is this part they want. Okay, then we can get the outside part, which is the part they want. Okay, so what we should write here is, okay, first thing, same thing, we integrate from 0 to k. I write 0 to k. After that, because we integrate in the y-axis, so behind here I have to write dy. Okay, so when I write dy here, means here I will get x. I want to substitute x here. Obviously, this question is very easy because it straight away gives you x equal to 4y minus y squared. Means you can straight away substitute 4y minus y squared here. So 0k 4y minus y squared, because this is equal to x dy. And then you just do the integration part. So if you're not sure how to integrate this one, actually you can straight away write something like this. Okay, you can straight away write something like this. And then 0 right on the bottom, k right on the top. And then after, when we integrate this one, 4y, we will get 4y, 1 plus 1, 2, divided by total power. And then minus y squared. Square is 2, 2 plus 1, we got 3, divided by 3. After that, we substitute the value into here. Okay, so this one should have no problem. Oh yeah, so if let's say this curve, he doesn't give you like this one so nice, he straight away give you the x. For example, maybe he give you, let's say, y will equal to x squared plus 7. So if he give you this curve, you want to substitute x here, you have to change this one to the x as a subject. So what you need to do is this one x will become
x squared will become y minus 7, and then x will become square root of y minus 7, and then you have to substitute the whole y minus 7 into here, and then you only start to integrate. Okay, obviously square root here you can change to y minus 7 power of 1 over 2, because this is square root, and then you just plus 1 divide by total power. That's all. Okay, so remember, when integrate in the y acid here, you have to put x, and then make sure this one is the x value. If this is the y value here, you change to the x, then only you substitute, because most of the students will make mistake when integrate in the y acid. Okay, so let's have a look on the volume. Okay, actually volume is very simple, but then you need to understand the concept, because concept is very important. Okay, let's see. He said this curve, okay, and then P to Q, okay, mean the whole shape region here, okay, he will rotate 360 degrees in the y acid. Okay, most of the students maybe cannot imagine how this shape region rotate 360 in the y acid. So actually I draw out something like a 3D diagram here. Okay, when you see this 3D diagram here, actually you will see the cylinder here. Do you see a small cylinder here? Okay, this is the surface of the cylinder, this is the height of the cylinder. Okay, so if you see, actually here we got 1 cylinder, 2, 3, 4, 5, 6, we got a lot of cylinder all plus together become the total volume. And actually this cylinder, actually when he accumulate, he will look like something like corn. Okay, anyway, this is a loss of difference of cylinder. So here we have to understand what is the formula for cylinder. Cylinder will be pi r square h. Correct or not? Volume for cylinder will be pi r square h. Okay, and then maybe I draw a small cylinder, give you some guide here. Okay, this is the shape of cylinder. Okay, and then this one we call it h, and r is the middle. So this is r, this is h, so this is cylinder. Okay, this is a small cylinder. Okay, so actually the formula for volume, they are come out from the cylinder formula. So when you want to integrate the whole volume, because actually he said this straight region will rotate 360 at the x at the y acid here, mean actually he will rotate. After he rotate, he will got some shape like this. So from here you will see the r actually is here, mean actually this one is the r, because after he rotate you will see a circle, so this one actually will become the r. Okay, and then this one will become the height of the cylinder. From here to here is the height of the cylinder. Okay, so why I explain this one to you is because when you write the formula for integration, okay, when you write integrate here, this integrate you have to write for height. The height here will be from Q to P. Q to P is the height of the cylinder. After that, okay, the R actually is on the x-axis, correct or not? The length of our R is on the x-axis. So this one, we straight away we write, okay, pi r square. So pi r square, r on the x-axis, so actually is pi x square. Okay, and then this is the height. Height is on the y-axis, so we write dy. Okay, maybe some of you still cannot understand, so you have to imagine this one when he rotate 360 degree, when he rotate 360 degree, okay, this one will become r, because you see when he rotate 360, the PR here already become the radius. Okay, radius we call it r. So actually this is pi r square, and then multiple h to get the volume, correct or not? So when he rotates 360 degree, this is pi r square, and r here actually is the length of the x-axis here, means the x value lah. If this is 0 to 7, so here will be 7, but then 7 here is from the x, so we straight away will write out pi x square h. This qp is the h, okay, because this actually is the curve. Means actually this one is from a lot of different shapes of cylinder accumulate together one. So therefore this one is, we call it pi x square and then dy, because actually when you say when you want to get the value from the y-axis here, you write dy here. Okay, let's have a look on this one. Okay, so now I want you to imagine, okay, I want you to imagine this diagram. He will rotate, this shape region will rotate 360 degree in the x-axis. So when he rotates 360 in the x-axis, you will got some volume like this. Okay, this is x-axis. When he rotate, you got a cylinder volume like this, and then maybe the volume will become smaller and smaller and smaller. Okay, and then this is the curve for y equal to gx. Okay, so when if you rotate 360 in the x-axis here, where is the r? R will be here. From here to here, this one is the radius. Correct or not? And actually this radius, the length of the radius is on the y-axis here. Means actually we get the length of the y-axis here. So the formula, and this one is the h. Do you see? This one is the h, and this one is the r. So therefore formula for cylinder is pi r square h. So pi r here is the the value on the y-axis here. So it's pi y square, and then our height here is based on the x-axis. So pi r square h will be dx. And then let's say this is from here a to b. So we write here a to b. That's all. This is the way to see volume. Okay, so if without, okay, we try to write one more time for this one without this diagram, because in the exam it's quite waste time to draw that diagram. So I want to practice. You can straight away see here. Okay, you assume, because you say this one, okay, this shape region will rotate 360 degree in the x-axis. So when he rotates 360 degree, okay, here will be the r, correct or not? Because you will have the cylinder here, and then in this cylinder will have, maybe will have the volume. So this one will be the r. So r you straight away connect to here. Okay, so in order to find the length of this one, we have to look at the y-axis here. So the formula for this one is called pi r square. So r here is referred to y. So pi y square h. H here is on the x-axis. So dx. And then from a to b. From a to b. Okay. That's all for this explanation of the volume and area, and maybe later I will post another videos about the past year question to make you all understand better about this chapter. Okay, if you all still cannot understand, maybe you all can comment on the y equal to mx+c Facebook page, and then I try to make it more easy to understand for you. Okay, and anyway, thanks for watching.